Since there is no given for our A, let's solve it first so we can compute our magnetic flux later.
Good day everyone, I am Miracle Ortiz and this is Group 1. Our report for today is all about the Faraday's law. Stating the Faraday's law of electromagnetic induction states that whenever a conductor is placed in a varying magnetic field, an electromotive force is induced. And if the conductor circuit is closed, a current is induced and that is what's called induced current. Faraday's law is also a quantitative relationship expressing that a changing magnetic field induces a voltage in a circuit. Faraday's experiment is showing induction between coils of wire. The liquid battery provides a current which flows through a small coil, creating a magnetic field.
Faraday's law of electromagnetic induction is named after the English physicist Michael Faraday, who first discovered it in the 1830s. Faraday was conducting an experiment on the relationship between the electricity and magnetism. He observed that a changing magnetic field could induce an electric current in a nearby conductor. Faraday's original experiments involved moving a magnet back and forth inside a coil of wire. He found that when the magnet was moved, an electric current was induced in the coil. He also observed that the direction of the current changed when he changed the speed of the magnet's movement or when he reversed the poles of the magnet.
Faraday's law have two law of electrolysis. First, and the second law of electrolysis. The second law of electrolysis states that the mass of a substance deposited or liberated at any electrode on a passing certain amount of charge is directly proportional to its chemical equivalent weight. And as you can see, this is a formula of the second law of electrolysis. That is the formula of the second law of electrolysis. W1 over W2 equals E1 over E2. W1 and W2 refers to the weight deposited of 1 and 2 elements respectively, and E1 and E2 refers to the equivalent weights of 1 and 2 elements respectively.
Since there is no given for our A, let's solve it first so we can compute our magnetic flux later. A is formula of a coil and its formula is pi r squared. Now, we substitute. Pi is equivalent to 3.14, r radius is 0.5 according to the given problem, and squared. Let us now multiply our pi and radius. The answer is 0.785 meter.
Hello, so I'm James Ryan Berineria, and today we're going to get the magnetic flux using this formula. Now we can find the magnetic flux by substituting the formula with the given. We substitute the magnetic field with 0.5 Tesla times area, which is 0.785 meters squared, times cos 0 since the angle is not given. First, we multiply the magnetic field and the area, and there we arrive at 0.3925 multiplied by cos 0 or cos theta, and there we have our magnetic flux, which is 0.3925 Weber.
So after getting our area and magnetic flux, we will now proceed in our induced EMF. And able to get the induced EMF, we will be using the formula E is equals to negative N times the change of flux over change of time. So we will just substitute our givens. Our number of loops is 1000 times our magnetic flux, which was calculated earlier, which is 0.3925. Then our change of time, which is given 0.14 seconds. So 0.3925 divided by 0.14 seconds is 2.50. Multiplied in our number of turns, which is 1,000. So, total 1,000 times 150 is 2,500 volts. So this is our final answer.
Hello, I'm Tyler Bismiago, and today I'll be talking to you about the mathematical formulas we will use in getting the EMF. In getting the EMF, we will use the formula negative n multiplied by delta phi over delta t, n representing the number of coils, phi representing the magnetic flux, and t representing time. In order to get the magnetic flux, we will use the mathematical formula B multiplied by A cosine theta. B, which represents the magnetic field, A represents the area, and theta represents the angle between a perpendicular vector, the area, and the magnetic field.
This is the procedure of getting the magnetic flux. First step is to solve the angle between the perpendicular vector of the area and the magnetic flux, simplify which is the cos theta. The next step is to multiply the magnetic field and the area, then multiply the answer from the magnetic field and the area to the answer from the cos theta.
This is the procedure on getting the EMF. Divide the change in magnetic flux to the change in time. Then multiply the answer to the number of coils.